So I think it's time to begin. I hope everyone who wanted to attend this meeting here with us now. Uh, today's topic is what can Galileo Sky, uh, which solution can we provide you in case that you need to work is in areas where there is no GSM network. What to do? What can we do in this case? Which solution can we provide to you? And I also will tell you about our projects of our partners, what did they do, which solution they use, and so on. So I think we can start again. Thank everyone who attended this meeting. I hope this information will be useful for you. And the record of this meeting will be available all of you. It will be sent to you via email, and it also will be available for you in on our YouTube channel. So please feel free to check our YouTube channel. It contains a lot of useful information, and it's always for free. Please join our YouTube channel. So okay, let's start. Let me start with telling about me. I'm Dmitry. My name is Dmitry. I'm the project engineer of the Galileosky. The planned duration of this meeting is about 60 minutes. And again, as I said, the record of this meeting will be available for you. And you can always ask questions. We have special buttons at the top of the window, so you can send your question in chat, send your question in special question tab. Please feel free to send your questions, and I will answer them. It depends on the questions, maybe during the meeting or at the end of the meeting and the Q&A part. So please feel free to ask your questions. About the agenda, so we will discuss which factors can influence the choice of different solutions in case you have you have to work in the areas with no GSM network. What you need to use or which equipment need to be applied in these situations. We will discuss some difference in work with the Wi-Fi network or GSM network, and actually I will give you some hints about how we manipulate Wi-Fi devices in case that we need to work with different channels. So I think why is the monitoring is necessary? It's not a question for most of you. I think it's obvious that we need why we need to monitor our vehicles, why we need to monitor different equipment and working area, and sometimes we as developers and you as the our clients you sometimes face issues when vehicles are not in areas where the GSM connection isn't available. So there may be different areas with no GSM coverage. There may be some specific areas like mines, like different fuel or manufacturing areas, oil station, and different situation when the GSM network is unavailable. So what can we do and why the Wi-Fi solution can be useful in these cases? So about possible application of Wi-Fi hub solution, our partners used our Galileosky Wi-Fi Hub device in different application. They are used in oil or gas fields in areas with no GSM coverage. They used for monitoring vehicles and different moving assets in far north where there is never will be GSM coverage, and many other things. So the first example of our partner project is the monitoring of heavy machinery in Kyrgyzstan. And what the task was. For 5 years, our partners they used usual GSM-based devices, but when the grow depth of the mine was higher and higher, it was the GSM signal was worse and worse. So after some times, it was obvious that the work via the GSM channel is impossible actually, and that's why the Wi-Fi solution was used. So there was different vehicles, different sort of vehicles in this area. Sorry, give me a second. So sorry for that. The different vehicles were used in this area. It was more or less movable vehicles like stationary equipment or tractors that were always in the area, and it was also used as different machines. And our clients used 7x Wi-Fi hub devices, which were installed in all vehicles. But there is a small difference in device settings. For vehicles that are always in the area, the Wi-Fi devices were set in the client mode, and they was sending the data to the refueling vehicle, which was moving from the area to the base where the GSM network was available. So the refueling vehicle was moving to the area and collecting data from clients that are always in the mine area. And then after returning to the area with the GSM coverage, the Wi-Fi hub device was sending its own data via the GSM server to the via the GSM channel to the server, and later it was sending the client's data to the server. And other devices, other vehicles that were also returning to the area with the actually to the base where the network was available. They were sending their own information by their own. So actually it was partially the GSM solution and partially the Wi-Fi solution. So which task was solved in this case? Our partner managed to make a count of races and areas with no GSM coverage. It was solution for monitoring the fuel, and also was the task of excluding the fuel ceiling was also solved. So it was fuel monitoring, and actually was solved the issue with stealing of the fuel. And another task was solved is the maintenance intervals of for the vehicles. So when you know where, when, and how long your vehicle was used, you can actually know when it's necessary to work with this vehicle and to send vehicles for maintenance. And one of the tasks also was to monitor the driver behavior. So eco-driving function also applied to the vehicle, and it allowed clients to monitor the driver behavior and solve the issue with different accidents. So actually all the tasks that were set before the integrator were solved, and solution decided to be successful. So As for timing, according to the client's information, the data collection process for the Wi-Fi hub device, which was collecting data from the clients, was about 5 minutes. So once the Wi-Fi hub, the data collector device, was near the client, it was taking about 5 minutes for the device to collect all the data from the client device and save it to the internal memory, to the micro SD card of the Wi-Fi hub. And the whole time of uploading data to the server for all devices, for all the data that was collected to the memory of the Wi-Fi hub was about 15 minutes. So the information was quite shortly uploaded to the server once the data collecting device was in the area. Is the signal. Okay, maybe let's switch to another case. The second interesting case of our partner is resource accounting and monitoring of drilling parameters on mobile or stationary objects. In case of mining, client was using the mobile or stationary equipment for mining and for the oil receiving. Sorry, forget the word. And the idea is that for this equipment, it is necessary quite impressive amount of fuel, and the numbers is about 3 to 15,000 liters per the day per working day for this equipment. So it was crucial to monitor this fuel and to know how much fuel was used, and it also was necessary to understand which equipment works correctly and to find out if the equipment has some issues. So the three tasks were set before the integrator. It was necessary to monitor the fuel for the actual equipment. It was necessary to monitor the fuel for that was used to set the temperature inside the main cap in the correct level, and the electrical generators also was used to generate power for equipment and for the camp, and this equipment also have to be monitored. So all this information should be collected by the devices and sent to the software. The client was using the industrial type of Wi-Fi equipment, which was provided the Wi-Fi connection for 7X devices. As you can understand, the GSM network is actually unavailable in this area, so the Wi-Fi solution was the only alternative for the Iridium devices. But the Iridium channel is quite expensive. That's why Wi-Fi solution is more interesting for the client and why it was used. So this solution allowed the client to again monitor the fuel usage in this project. It allowed client to check if the fuel was stolen. All this information can be again was available in the server and studying of this data allowed client to prevent fuel stealing. The client was also using the special equipment, the special electrical counter for the electricity, and monitoring of the electrical power supply also allowed client to understand how much electricity was used and to improve this parameter too, because some necessary used electricity was found during the studying of the information, and this parameter also was improved during this project. It's interesting that temperature in the area of this project was changing during the year from -50 to +50 degree of Celsius, and because of this, it was necessary for the client to install the Galileosky device in the special case, which was protecting the device from the weather, from rain, from snow, from the temperature, and so on. So, and again, the Wi-Fi solution helped the client to solve of all tasks and to get data in the area where the GSM network is unavailable. The next interesting case is about, again, fuel monitoring in the Arctic Circle when the temperature is less than -55 degree of Celsius. And in this case, Wi-Fi solution allowed client to monitor fuel usage, monitor the usage of the vehicles, and it also helped to check the driver behavior and prevent accidents on the roads, because in such conditions accidents can actually be dangerous, because if your vehicle stopped in this condition, it's almost certainly will never start again. So people just can die because of the cold in this area, and it was crucial to monitor driver behavior to prevent accidents. The solution also allowed the client to monitor work of equipment, check operation hours, and so on. And the counting of number of completed trips allowed client to understand how the vehicle used, and if there is some unnecessary movement of the vehicle were presented. So this information actually again save money for clients and also prevent accidents. So it means it saves lives. As for the solutions itself, the client again was searching for the solution for the alternative for the iridium channel, because again the iridium channel is quite expensive and it's quite hard to send too many information via the iridium channel, because it takes money, it takes time to get this data, and Wi-Fi solution was considered as the nice alternative. At the start of the project, the client was working with only 10 vehicles. It was different vehicles, fork loaders, bulldozers, heavy equipment, and vehicles for moving the personnel, like small buses. And at the start of the project, they were playing with the test equipment in conditions that are quite new to the real conditions. So the devices was working basically in the GSM area, but the SIM card were taken from the devices, so that devices would work via the Wi-Fi channel. After some several months of testings, clients was happy with this solution, and after that, all vehicles were equipped with the Wi-Fi devices. They were configured, tested, and then sent to the working area near the North Pole. And after that, so again, clients was able to get information from devices, monitor the equipment, check fuel usage, and get all the information they are necessary. Why Wi-Fi solution in this case is helpful? Because you actually not really limited by the amount of the data that can be sent. You can send any information you need, because having the Wi-Fi connection allows you to send almost any amount of information that can be necessary for you. So you don't need to limit yourself, as is what have to be done in case of using the iridium channel. Again, as I said, the iridium is quite expensive, and when clients use iridium channel, they should consider the accounts for the communication and limit the data that can be sent. In case of Wi-Fi, you don't need to think about it, because Wi-Fi channel, once you have it, it allows you to send any data you need. So again, after testings, after test, the equipment was sent to the actual area, and the most interesting point of this project is actually uh, Franz Josef Land, which is 800 kilometers from the North Pole, which is quite cold place, but still 7X devices, they work perfectly in this condition, and this project was also considered as successful. And I think the last interesting example of successful projects, there was actually uh, much more of them, but we decided that this is the most interesting, and it's interesting uh, to tell you about them. And again, this project was about monitoring vehicles, movement of the vehicle. It was about monitoring the fuel consumption, and again, it's about monitoring the driver behavior on roads in order to prevent car accidents. As you understand, again, vehicles was moving mostly in areas when the GSM network is unavailable. So, Wi-Fi solution was considered by uh, our partner, and they started the tests. So, uh, in this project, about 500 vehicles were used. Again, it's different vehicles for roads, buildings. It's different vehicles that are used in the process of building of roads, and all this data again should be collected, should be sent to the server. And as you can understand, in process of building roads, it's again impossible always to work in areas with GSM connection, and in case of the far north, there is no much such areas. So all equipment that was used in this project was equipped with the Galileosky 7X Wi-Fi devices, and the scheme was the same. All vehicles that were always presented in the area were equipped with the 7X devices that were working in the client mode. About different modes, I will explain you a little bit later. I will explain how this equipment works. But again, vehicles were equipped with 7X devices that were working in the client mode. They was collecting data to the internal memory, and then when the data collector device was in the area, uh, the data was sent to the collecting device and sent to the server later. Why this project is interesting is actually because our partner was using different approaches to different tasks. In case of road building process, they was again using the referring vehicle for collecting data from vehicles from equipment, and then this referring vehicle was returning to the area with the available data transmission channel, and this server was sending data to the server. But for building, for places where building were built, client was using the actually hand device. It was special equipment built for this project. The device, Galileosky device, was installed in a box that was moved by hands by one of the workers in this project. And they were moved to the area where the building was built. The device, the Galileosky device, was automatically collecting data from equipment, from vehicles, and later this special box was moved to the office where the Wi-Fi network is available, and it was manually switched to the client mode so that the device could connect to the local Wi-Fi network and upload data that were collected from different equipment. Uh, it was uploading data via the Wi-Fi to the server. So it's quite different approach. You can install, as you can see, you can install the device to vehicles. You can install device to the special box with the battery, and actually can be the device can be moved by hands with the specially studied people. So, and again, the timing is quite interesting according to the data that we received from from this project. It was usually taking about 5 minutes for the collecting device to get all the data that was stored in the client's memory for the whole day, and it was taking about 5 minutes. So the Wi-Fi channel is quite fast. It allows you to transfer quite the data via this channel, and it not taking so much time. So Wi-Fi solution is quite interesting in this case. And again, all the data that was collected to the Wi-Fi 7x Wi-Fi hub that was working in the hub mode with working in the data collection mode. It was taking about 15 minutes to upload all the data that was collected in its memory from clients. It was taking about 15 minutes to upload all collected data via the Wi-Fi channel. So again, it's quite fast data transmission channel, and that's why it's so interesting. And again, you don't need to think about traffic. You don't need to limit yourself in parameters that you want to get from the vehicle. You can collect all the data you need from vehicles and have this information in the server. So, as you can see, Wi-Fi devices were used in different projects in quite harsh conditions near the North Pole, in different tasks to monitor stationary devices, to monitor vehicles, to monitor special equipment, and even such special equipment as generators, as mining equipment, and so on. So the devices, they are quite universal. They can monitor different equipment, and 7x Wi-Fi devices, they are actually the same 7x devices that have such the same functions, the same interfaces like CAN, REST interfaces, digital interfaces, analog inputs, and so on. So it's the same device, but it's also equipped with the Wi-Fi transmission channel, and it's like addition to the functions, not the function that was set instead of something else. And I think it's time to give you some theory how such devices works, and again, the Wi-Fi solution is not only one solution. We also have the Iridium devices. In some cases, Iridium also can be applied despite the price of this solution. But again, I will switch to the Iridium device at the end of this meeting. So again, vehicle monitoring process. It's not necessary to explain you why it is necessary, why you need to get data from a vehicle, why you need to monitor your equipment. It's actually obvious. But again, in some cases, the GSM network is unavailable, and in this case, you need to try to find some other solutions. In case of using the Wi-Fi devices, you actually can work in any area, because in most cases your equipment is not always in the area with no GSM coverage, and even if it is, even if your equipment is always in the area with no GSM coverage, you still can you still almost certainly have some vehicles that are moving in some specific area where the Wi-Fi network is available, or the GSM network is available. That's why Wi-Fi solution can be applied, because once you have such vehicles, such special vehicle which travels from the area with no GSM connection to the area where some communication channels are available, In this case, you can use a Wi-Fi solution. Again, you don't need to think about amount of the data. You can collect all the data you need with the Wi-Fi solution. You are not limited by the cost of the data communication channel. And again, this solution helps you to solve your different tasks. As I said earlier, the 7X Wi-Fi Hub device is quite the same as usual 7X device. It has the same interfaces, digital interface like RS485 or one-wire interface. It has two CAN buses. It has inputs and outputs. It supports Bluetooth communication channel so that you can use uh, wireless sensors to collect different data from your vehicles, such as BLE, fuel sensors, and it also supports micro SD cards so that you can improve amount of data can be stored in the memory. It supports CAN bus, it supports eco driving, easy logic, and all interesting features that's supported by usual 7X devices. Again, it's just improved version of Galileosky 7X. And so all features that are available for usual 7X, they also available for Wi-Fi devices, and means that if you are using 7X devices, you are familiar with this equipment too. It has just some small improvements. And again, about this scheme, Wi-Fi 7X Wi-Fi devices, if you are speaking about 7X Wi-Fi, they can work in two modes. The device can work as a client. It means that in the device settings, you can set up the APN parameters for the Wi-Fi access point. The settings, they are quite the same as if you're connecting your cell phone to existing Wi-Fi channel, Wi-Fi hub, Wi-Fi router. You need to set the name of the network, you need to set the password, and then actually you can connect your device to the existing Wi-Fi network. It's the client mode. In this case, the device can work again with the two channels. You still can equip your device with the SIM cards. In this case, the device will work via the GSM channel if the GSM channel is available, and it also constantly searches for the Wi-Fi network that you set. As soon as device finds this Wi-Fi network, it will connect to the Wi-Fi, because we think that Wi-Fi is almost free, it's cheap, so it's better to send data via the Wi-Fi channel because it's fast, it's cheap, and it usually has unlimited amount of traffic. So why is this preferable by the device? So the switch is automatic. As soon the device detects the Wi-Fi channel, it switches to the Wi-Fi channel and sends data via the Wi-Fi. Again, via the Wi-Fi channel, you can use remote configuration, you can download scripts, you can update firmware, it doesn't matter, all these functions, they are available via the Wi-Fi channel. And since the Wi-Fi is quite fast data communication channel, in compare to the GPRS channel that usually used in 7X devices, it's actually much more convenient to work via the Wi-Fi if it's available. So that's why the device automatically switches to the Wi-Fi mode. And this it is like a first step. It's a simplest approach to this task. You just can work via the GSM in the client mode or via the Wi-Fi. Again, the switch is automatic. The second way for the device, I think I need to change the picture. Yeah, this picture actually shows you different schemes, how the data can be sent via the Wi-Fi channel. It's not only the client mode. We have several interesting solutions for you. And the second mode for the 7X Hub, you can see this client pictures, hub pictures. So the second way for the device to work is the hub mode. It is much more interesting mode for the device, because in this case the device actually is not sending data via the Wi-Fi, it's collecting data via the Wi-Fi. So again, settings, they're quite the same. You need to set the name of the Wi-Fi network that's provided by the hub, and the password. For the client, you can set the same settings. And in this case, the hub device, the device that works in the hub, the data collector, the hub mode, it will collect data from clients. So in this mode, the device is collecting data from different devices that are working in the client mode. So once the hub device collected the data from clients, this data is stored at the device micro SD card. I see the question. If you don't mind, I'll answer later after the presentation, because yeah, it's quite long. So I will explain the different schemes. I almost ended, so I hope I'll answer a question later. So the hub device is the same device, but it has different just small difference in settings. It's collecting client's data to the micro SD card. This device still collecting its own data. It can be stored at the micro SD card. It can be stored in the device internal memory. It doesn't matter. You can set any parameters for this device, but client's data is always saved to the micro SD card. So if you are interested in this solution, please be careful with choosing micro SD card, because again, this equipment usually used in quite harsh conditions, so you have to be careful with choosing of the micro SD card. You need to choose micro SD card of high quality, because if micro SD dies, you're losing all the data that was saved to the micro SD card. Please be careful with it. But basically, the device that is set in the hub mode, it saves all the data from clients to the micro SD card, and there are two possibilities for the device. Again, as I said, you can still equip your hub device with the SIM card, so that it could connect to the GPRS channel. You can equip it with the Wi-Fi settings, so that the device could upload the data via the Wi-Fi channel if it's available. It depends on your task, it depends on your project. But for the hub device, it's still the same. And what is actually interesting, what is good for you as a client, is that all the logic of data uploading process is inside the hub device. What's happening next when the hub device has the communication channel? It doesn't matter if it's Wi-Fi or GPRS, but the logic is the following. The hub device is connecting to the server and uploads its own data from its own memory. So at first, when the hub device is in the communication area, you can see at the server that the hub device is connected to the server and uploading its data. You are receiving his own archive of the data. After some times, the hub device is disconnecting from the server and connecting to the server as the first of the client, checking its own memory, and connecting to the server as if it was the first of the clients. It's sending data, again disconnecting, and connecting as the second of the clients, and until all the data is uploaded. So why is it interesting? Because you don't need to improve your server. Again, all the magic is inside hub device. All the process automatic. You don't need to improve your server. You don't need to add different tags. You don't need to improve the protocol. It is still the same usual Galileosky protocol, and you can use any software that supports Galileosky protocol. You don't need to make changes from the server side. You're just receiving the data from your vehicles as if they were in the GSM coverage area. That's why it's so interesting for you, because you just need to do correct settings on the devices, and that's all. Once the Wi-Fi hub device is in the coverage area, it will send data, its own data and client's data. And what is interesting in the in the second scheme is actually that's your Wi-Fi device that works as a hub mode, as the data collector device, data collecting device. You can still switch it to the client mode so that the device was able to connect to the existing Wi-Fi network. Again, I think for people who are familiar with our equipment, the answer to almost all questions is easy logic. Yeah, you can create the simple algorithm that changes the Wi-Fi settings for the device. The trigger for settings might be geofence, it might be button, it can be switch, it can be anything you can imagine. Again, with easy logic, you can use any solution you need. But I think the most common approach in this case is switching the mode by the easy logic according to the geofence. So you can describe the small geofence at your base, for example, where the device should switch to the client mode and connect to the local Wi-Fi network. And the algorithm will check the coordinates of the device and switch the device to the client mode in case that the device should connect to the existing Wi-Fi network. Again, you're just creating algorithm. You can download the example of the algorithm from our servers, from our site. We have a list of available samples of easy logic algorithms. It's quite impressive list of algorithms available there, so please feel free to use it. It can be helpful. Algorithm has descriptions. You can download this algorithm and use these algorithms as a base for your personal projects. So again, we have an example for Wi-Fi mode switching algorithm. You can use it, you can download it and use it in your own project. Again, according to our experience, the switching via the switching of mode based on the geofence is one of the most common approaches by our clients. But again, it can be different approaches. You can build a complex scheme when the data from client can be sent with the several hubs. So the one data collecting device can switch to the client mode, upload all the data to the second device that works in the data collecting mode, and so on. But I actually can't remember any such examples in practice because this scheme can be too complex, because too many things can go wrong in this case. But yet it's still possible if your project requires such solutions. Such solutions can be created. You can use this scheme. It's quite possible. And I think the most common scheme is the last one, when the hub device, data collecting device, is collecting data from several clients. For now, at the time, only one client can be connected to the Wi-Fi hub device. But in most cases, it's not the issue. Again, according to our experience, the data uploading process for the single client takes about several minutes. So it's not a problem. Clients are connecting to the device hub on of the time, one by one, and uploading the data. Again, in most practical cases, it wasn't an issue, and the scheme works perfectly. So once the hub device is in the GPS area or the Wi-Fi area, it uploads its own data to the server and the client's data to the server. And this scheme is used in practice by many of our clients, many of our partners. And again, I just told you about different examples of such projects. There are actually much more of them. And the last but not least, we actually have not only the Wi-Fi solution. In some cases, Iridium channel is still necessary. Why is that? Because sometimes it is crucial to get the data as soon as possible. For example, it can be SOS signal from the device, because if your these devices can be used on different ships, and you need to send the SOS signal as soon as possible. You need to send it immediately. The radio channel is preferable because it works as soon as you actually press your SOS button, and the signal will be sent. And yeah, I agree with you that the Iridium channel is much more expensive. It costs quite impressive, but in comparison with the people lives, it actually doesn't matter. If you need to save your equipment, if you need to save people, the Iridium channel is the solution that is what you need. Again, the Galileosky base block Iridium is the current version of Iridium device for now. I actually don't know uh, if we are working on the Iridium solution based on the 7X device or not, because I heard about such projects, but for now the actual solution is the base block Iridium, so it can be bought. You can use this device. Again, many clients use this device to monitor equipment in condition when the GSM is unavailable, and Wi-Fi solution can be work, because in some cases you just don't have places where you can place the Wi-Fi access point, or when your equipment works alone, like ships, or maybe some other cases, and you need to get the data no matter what. So in this case, the Iridium channel is preferable for you. And I think we quite often, yeah, that's why these cases when Iridium channels was used, again, as I said, it's used to control icebreaker. Again, if you need to get the data from such far away, like icebreaker, the Iridium channel is what you need. And it also can be used for monitor different parameters of your ship. Again, fuel consumption of the ship, it's quite impressive. If you need to monitor such parameters, you can afford paying for Iridium channel. Again, it depends on the process. And yeah, one of the most interesting cases for us is the monitoring of vehicles in yeah, rally road. It's a very interesting case when we're monitoring sport cars. So again, this solution provides a communication channel in this interesting task too. Yeah, and again, our clients quite often ask us about the traffic consumption, data consumption by the Iridium channel. And here you can check small calculations, how much data the device will send via the Iridium channel, for example, for the day, or maybe for the month. You can make such calculation by your own. In this example, you see the data package is 11 bytes. 11 bytes, it's a specific set of data. It's called minimal data set, which contains date and time, coordinates, validity of coordinates, alarm flag, and on user tag. Before using this tag, it's better to contact the server support and find out if the server supports Galileosky with compression protocol, and if they are supporting, if the software support minimal data set, because it's a quite specific sort of data. This data is packed by a specific way in order to put as many data to this 11 bytes as possible. So it's better to contact the support team of the software and ask if this data can be sent to the server, because not all software support this data pack. But I know for sure that Gurtam system, while on, it supports minimal data set perfectly. It supports Galileosky disk compression protocol. So with the if you're using while on, you can use this minimal data set, and all this calculation they might be useful for you. But again, you can make all this calculation easily, and based on this information, you can check if the Iridium channel is actually affordable for you in your project or not. Okay, yeah, and obviously, yeah, the most interesting part of the Iridium solution is that it's working everywhere. You don't need any other communication channel. Your device is like almost always online when it is under the clear sky, in underground parkings, in the caves or in tunnels. Okay, it's obviously will not work. But in most cases, your device can send data to the server all around the world. And why is the base block Iridium device is so interesting? Because again, it has two channels. It still supports GPRS channel, and the device automatically enables Iridium channel only in case that the server is unavailable via the GPRS channel. So as soon the device loses the GPRS channel, loses the GSM signal, the device automatically switches to the Iridium channel. And one of the advantages of, again, base block 7X device is that you can configure the data package for the GSM channel and the Iridium channel independently. Obviously, you will not want to send all the data that you are sending via the GPRS channel, via the Iridium channel, again, because it's expensive. But in other case, you don't want to limit yourself by amount of data in case you're using the GPRS channel, because it's quite cheap. You can send any data you want. It's not so expensive. So you can configure data packets for GPRS channel and for the Iridium channel independently. As soon the device switches to the Iridium channel, it starts sending data that you set in the satellite packet. The settings, they are the same as for the main packet of the data at the track page, just a satellite packet in addition to the main packet in the device settings. So you can set these data packs independently, and the device switches between channel automatically. You can set any period of data sending via the Iridium channel, and the initializing of the Iridium modem is also available for you from the easy logic. Yeah, so again, you can create any logic for your device and attach the sending of the data packet with the Iridium channel according to your task to almost any event that can be detected by the device. Again, so it's quite flexible solution. You can create any logic you need, but I advise you to be careful with this because in my experience we had some quite interesting situations when by the mistake client was sending data via the Iridium channel because of the wrong algorithm too often, and it was quite expensive experiment in their case. But basically, if you are able to create a correct algorithm that works according to your task, you can manipulate by the Iridium modem. You can send data via the Iridium channel according to your task in the flexible way. So again, it can be set the stational period of data sending, or you can manipulate by this period via the easy logic. Again, it's quite flexible solution. We have some pre-install events that send data via the Iridium channel in case of absence of the GPS channel. For example, it's the panic button. If you have set the device for working with the panic button, the base block Iridium will automatically send the point at the moment when you are pressing the panic button. It works automatically. You just need to set parameters for panic button at the signaling page, and that's all. The device will automatically send the message about the panic as soon as it detects the panic. So what else do we have in our presentation? Yeah, I think I almost everything was already told. Again, the device automatically switches from the GSM to the Iridium, and from the Iridium to the GSM. As soon the GSM connection is available for the device, you don't need to make additional settings. The device works automatically. We have different data packets for the Iridium channel and for the GSM channel. The data from the device memory will not lost. As soon the device returned to the GSM coverage area, all the standard archive will be uploaded by the device to the server. So as soon the device returned to the GSM coverage area, all the data from the device memory will be sent for you. So it will be available for you on the server. But still, while the device in area with no GSM, you will still receive the data via the Iridium channel. It will be much shorter package of the data, but you will know about your vehicle, the information you need. And yes, you don't need to use any additional equipment for the base block Iridium device. The Iridium Iridium module is installed in the device. You just bind the device. You just uh, searching for the Iridium operator, register your device, and in your account settings, you just need to set the server where the Iridium provider should send data from the device. And actually, that's all. Settings, they are quite simple, and I actually don't remember any issues from clients that they couldn't set the device to work correctly. Again, in most cases, the base block Iridium device is quite the same as usual base block device, and I agree that it has a little bit less interesting functions in comparison with the 7X device, but still, it's the Galileosky device. It's reliable, it's high quality device, and with the Easy Logic, you can improve almost any functions you need. Again, Easy Logic is supported by the base block devices. Yeah, actually, I'm about Easy Logic. Yes. Again, both devices, 7X and base block, they both support Easy Logic. You can create algorithms for any events you need. You can solve your task with Easy Logic. It's quite flexible way for changing the device settings. You can manipulate modules, you can create reaction to different events, you can even integrate additional equipment if you are familiar with the scripting language. And in this case, you can actually connect on almost any equipment you need to Galileosky devices. If you are not familiar with the Easy Logic, I again recommend you to check our YouTube channel. We have several interesting tutorials for Easy Logic. It is Easy Logic Creator's Guide. It's like a basic approach to this task. And since recently, we also have Easy Logic Practic Guide, which is available for you for free again on our YouTube channel. Please feel free to watch it. And according to my experience, this information is enough to solve almost any task you can face, to solve any project you need. So please feel free to check our YouTube channel. I believe my colleagues will share the link to our YouTube channel with you in the email. I hope you'll join our channel. It contains a lot of interesting information. Okay, thank you for your attention. I think I'm finished with the information that I wanted to share with you. If this meeting is interesting for you, we actually planning to run one more webinar about this topic, but in this webinar, I will tell you about the practical part of this question, because this part was about the functions. But if you are interested in this solution, if you are interested in it, there are quite a lot of information that should be explained. There are some interesting things in settings. There are some technical parts that should be done correctly. Settings, hardware part, and so on. So please follow the news on our website. Please check your emails, because I think if this question is interesting for you, we'll run one more meeting, and in this meeting I will tell you about the practical task. I will show you some examples of easy logic algorithms, and what was created new since recently for Wi-Fi solutions, because now we have many interesting features available. So please again check news, check your email, and please join me in this meeting. For now, I can't tell you when this meeting will be, but again, check news, follow the news. So we have one question in the chat for now. Please feel free to ask more if you want to know something. Hello, I have a question regarding coverage GSM and GNSS. Is there any way if a device stops responding, we can do self-diagnostic mode, and what are the minimum conditions for signaling of GSM and GNSS we can use in the script to let the vehicle start directly? Thank you. Sorry, could you please give me more information, because yeah, as for GSM, in the GSM diagnostic mode, you can find the parameters like GNSS, and according to our experience, sorry, not GNSS, CSQ parameter shows the signal strength of the GSM signal, and if the plus CSQ parameter is less than 10, in many cases it is impossible to establish GPRS channel for the device, and in most cases it's not the GSM, not the device issue. In most cases, when the signal is poor, the provider just don't allow the device to register in the network. So it's about GSM. No GNSS coverage. No GNSS coverage. Is there any way if the device stops responding, we can do self-diagnostic mode? Yeah, basically you can run the self-diagnostic, but you cannot reset the device via the easy logic. This restriction was made by the safety measures, because if the reset function, if the reset command was available in the easy logic, it was possible to create the algorithm by mistake, for example, which will set the device to restart constantly. That's why the reset command is unavailable in the easy logic, but we have the firmware which contains the self-diagnostic feature. It is very flexible. It allows you to monitor almost any parameters you need and set the device to restart. For example, if the device is unable to establish GPRS connection or can't see GNSS signal, satellite signal, I actually advise you to contact our support team and ask about it, because it's quite new feature. It is available on the beta firmware 4T for 7X devices. This is a special page in the device configuration. It's called self-diagnostics, and there are many different parameters that can be monitored by the firmware and set the device to restart automatically, or set some specific module automatically in case of some events like absence of GSM signal or absence of GNSS signal, so we can set the device to restart the model or restart the whole device if it's necessary. So again, it is better to contact our support team, because this feature is quite new, and there are many things to discuss, and it's better to ask specific questions about this feature. How can you install this firmware, how you can configure this settings, how you need to configure the device for this feature. So please contact our support team. You can contact us via the email. Please send the support email in chat if it's possible. Thank you. And we have also a Skype channel. We have the chat on the website, but again, according to my experience, it's better to contact via the email because the answer can be quite long, and if you are contacting via the email, the answer will always be available for you in the email. So please feel to contact us, and we will explain you how to configure device for self troubleshooting. Okay, I see additional information. Can do self-diagnostic script, or what is the minimum parameters for GSM and GSM assess? Yeah, I see. I think I understand your question correctly. Yeah. Again, sorry, but you can't restart the device from the script. The reset command is unavailable. You can turn on and turn off the module, and in your case, if you still want to play with Easy Logic, I think it's possible because via the Easy Logic you cannot reset the device, but you can turn off and then turn on the GSM module and GPS module. It's possible. We have these features available for you in Easy Logic. And okay, immobilization based on signals. Okay, I see. Sorry, but I think it's very specific question because I need to know more about your task. Could you please contact me via the Skype or Galileosky support Skype? It is in my responsibility. I think we need to discuss just this task for you because I need more data to provide you the best support we can. Too many questions to not much information. So please contact me via the Skype. We will discuss this question in private. So maybe someone have more questions. Please feel free to ask in chat. Okay, no questions at all. Okay, I think we wait for 1 or 2 minutes. Again, I strongly recommend you to check our YouTube channel. This meeting will be available for you, I believe, tomorrow, at least at the end of the day. Once the video will be available for us on this platform, this webinar will be available. Please feel free to attend. We have many different tutorials on the YouTube channel. We have CAN Pro tutorial. It can be interesting for you if you are interested in the CAN scanner feature of our devices. We have easy logic tutorials on our YouTube channel and short tutorials for different features that are available for you, and also usually explaining new features that we added to the device functions. So again, if you want to know everything about our devices, please feel free to check our YouTube channel. And maybe if you want some questions to be discussed or to be described in more details, you can also contact our support team via the email, or you can contact us via the Skype channel, and maybe give your suggestions which information should be discussed in more details. We will think about it. It maybe run more new webinar, or maybe we will create new videos. It depends on the task, but basically, if you want to have more information, please feel free to contact us. We actually are always ready to assist you to get this information. So still no additional questions. So yeah, okay, perfect. So thank you for your time. I hope this meeting was helpful for you. Follow the news, check our YouTube channel, check your email, because I believe we will discuss the technical part of this Wi-Fi solution too. It will be more technical. I will explain you settings. I will show you several examples of algorithms. It will be less pictures. It will be more configuration software. I will explain you how to make all settings correctly, how to get the information from the devices, how to make settings. And we will also play with algorithms, because now we can visualize the data transmission process for the client, for the Wi-Fi data collection device. So you can inform your driver, for example, that the data collection process isn't ended, so he need to wait for some several minutes to allow the device to collect all the data and everything else. So again, thank you for your time. Please feel free to join our YouTube channel. Please feel free to contact our support team if you still have any questions. And have a nice day. Thank you for your attention.